Hello, welcome friends. Me Anila. The topic of my discussion is about Fehling test. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on Fehling test part 1. But before this, I will tell you something about Fehling test. This test is used for the detection of aldehydes and reducing sugars like glucose, fructose, which are monosaccharides, and disaccharides such as lactose, maltose. But this test doesn't detect sucrose because sucrose is non-reducing sugar. In this test, what is the procedure of this test? Fehling solution A contains copper sulfate, that is blue color. Fehling solution B contains potassium sodium tartarate in strongly basic medium, that is sodium hydroxide. For this test, we have to add equal amount of Fehlings A and Fehlings B, add sample, that is aldehyde or reducing sugars, and heat. If the test is positive, then red precipitates are formed. If test is negative, then blue color remains same. In this test, aldehyde or reducing sugar reacts with copper in the basic medium to form carboxylate ion, copper 1 oxide, and water molecules. So, if this test is positive, that means reducing sugar is present and the color turns red. If test is negative, for example, in case of sucrose, the test is negative because sucrose is non-reducing sugar, so blue color of copper sulfate remains the same. In this video, I will tell you how to solve toughest numericals on Fehling test part 1. Example number 1. A sample contains 0.01 mole aldehyde, but only 80% reacts with Fehling solution. Find mass of copper 1 oxide formed. In this example, moles of aldehyde are given and only 80% reacts with Fehling solution. We have to find the mass of copper 1 oxide formed. Solution. Because only 80% reacts with Fehling solution, we have to find that moles which are 80% of 0.01. We will write moles of aldehyde divided by 0.01 multiplied by 100 is equal to 80%. After solving, moles of aldehyde are calculated to be 8 exponent minus 3 moles. Because 80% of 0.01 mole reacts with Fehling solution and that much amount is 8 exponent minus 3 moles, we have calculated moles of aldehyde. This much moles of aldehyde reacts with Fehling solution. We have to find the mass of copper 1 oxide, that is red precipitate formed. Aldehyde and copper 1 oxide, it has 1 is to 1 ratio. As I have told earlier, aldehyde reacts with copper in basic medium to form carboxylate ion and Cu2O plus water molecules. So the aldehyde and copper 1 oxide has 1 is to 1 ratio. Since 1 mole aldehyde produces 1 mole Cu2O, so 8 exponent minus 3 moles aldehyde produces 8 exponent minus 3 moles copper 1 oxide. We have calculated moles of copper 1 oxide. Now we have to calculate mass of copper 1 oxide. But before this, I will calculate molecular weight of copper 1 oxide. Molecular weight of copper monoxide is equal to 2 is the number of copper atom into 63 is the 63.5 is the atomic weight of copper, plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, molecular weight of copper 1 oxide is calculated to be 143 gram per mole. We have calculated moles of copper 1 oxide and molecular weight of copper 1 oxide. Now we will calculate mass of copper 1 oxide is equal to 8 exponent minus 3 moles into 143 gram per mole, that is molecular weight of copper 1 oxide. After solving, mass of copper 1 oxide is calculated to be 1.144 grams. So in this way we have calculated mass of copper 1 oxide. Example number 2. 0.01 mole aldehyde reacts with Fehling solution containing 0.025 moles copper plus 2. Find the limiting reagent and the excess copper plus 2 left. So, in this example, two reactants are given. 0.01 mole aldehyde reacts with Fehling solution containing 0.025 moles copper plus 2. We have to find which of them is a limiting reagent. Limiting reagent means that limits the reaction, that limits the formation of products, that is producing less product. It is called limiting reagent. And the excess copper left we have to find. Solution. First we will see either aldehyde is limiting reagent or either copper plus 2 is limiting reagent. We have to find it by a method. I will tell you. If aldehyde is limiting reagent, 1 mole aldehyde produces 1 mole copper 1 oxide. So 0.01 mole aldehyde produces 0.01 mole copper 1 oxide. So the amount of aldehyde is given. 0.01 mole is producing 0.01 mole copper 1 oxide. Now we will check whatever the amount of copper 1 oxide is formed by copper plus 2. If copper plus 2 is limiting reagents, we will write 2 moles copper plus 2 produces 1 mole copper 1 oxide. So 0.025 moles copper plus 2 produces 0.0125 moles copper 1 oxide. So in the previous case you have seen, previous slide, you have seen the amount of copper 1 oxide is producing less in case of aldehyde and greater in case of copper plus 2. So that means aldehyde is limiting reagent because it is producing less moles of product, that is copper 1 oxide. So aldehyde is limiting reagent and copper plus 2 is excess reagent. We have to find excess reagent, that is copper plus 2. For this we will write 1 mole aldehyde reacts with 2 mole copper plus 2. This is according to the equation. 1 aldehyde and copper plus 2 has 1:2 ratio, mole ratio. So 1 mole aldehyde reacts with 2 mole copper plus 2. So 0.01 moles aldehyde. These are aldehydes that I have calculated in previous slide. So 0.01 moles aldehyde reacts with 0.02 moles copper plus 2. Because aldehyde is limiting reagent, so we will write its moles. It reacts with 0.02 moles copper plus 2. Total copper is, as already given in the example, 0.025 moles. It is total copper. We have total copper already given in the example. The reacted copper is 0.02 moles copper that we have calculated now. Now excess copper is equal to total copper minus reacted copper. So 0.025 moles minus 0.02 moles is equal to 5 exponent minus 3 moles. So excess copper is calculated to be 5 exponent minus 3 moles. So we have calculated excess copper. In this way, aldehyde and different reducing sugars are detected. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.